Slide 1. In reliability engineering, we often celebrate an initial pass condition. Strength is higher than applied stress, the margin looks comfortable, and the design appears safe. But that logic quietly assumes that both stress and strength stay constant over life. Strength erodes, stress can rise, and a design that looks robust today may drift into failure risk tomorrow. The stress-strength interference model treats load and strength as distributions, not fixed values. That matters because failure does not wait for the mean stress to exceed the mean strength. It begins when the tails overlap. At beginning of life, that overlap may be tiny. As the product ages, the overlap grows, and with it, the probability of failure. SSI is powerful because it captures two things at the same time: separation between the means and variability in both populations. If stress and strength are modeled as independent normal distributions, the reliability index beta is the mean separation divided by the combined standard deviation. That means degradation is not only a shift problem, it is also a scatter problem. Even if the average still looks acceptable, wider variation can drive a large increase in failure probability. In real products, both distributions evolve. Strength tends to shift left because of fatigue, wear, corrosion, creep, or microstructural damage. Often it also widens, which means unit-to-unit variability becomes more dangerous over time. Meanwhile, the stress distribution may move right as users demand more, environments become harsher, or cycling accumulates. Reliability loss is therefore not a single event. It is gradual margin erosion. This is why accelerated life testing exists. By increasing temperature, humidity, voltage, or mechanical load, we speed up the same underlying failure mechanisms and observe degradation sooner. In Arrhenius-based temperature acceleration, the acceleration factor depends exponentially on the inverse absolute temperatures and the activation energy. Used correctly, ALT does more than produce a failure time. It shows how the strength distribution evolves so we can project when it will begin to interfere with the load distribution in the field. Standard environmental tests should be treated as degradation checkpoints, not simple gate reviews. JESD 22-A104 is widely used for thermal cycling. JESD 22-A101 covers humidity bias exposure, and IEC 60068-2-14 is broadly used for temperature change and thermal shock evaluation. The real value is not the word pass. The real value is measuring how strength shifts at each life-equivalent checkpoint and using that trend to forecast interference risk. Consider an EV charging connector. At the start of life, retention force strength has a mean of 42 newtons with a standard deviation of 3.5 newtons. Plug load has a mean of 14 newtons with a standard deviation of 3.2 newtons. Using the normal stress-strength reliability index, beta is about 5.9, which implies an extremely low probability of failure. Now age the connector. If tribological wear reduces the strength mean to 28 newtons and widens the spread to 5.8 newtons, beta falls to about 1.95. That is a dramatic loss of robustness, driven not only by lower average strength but by higher variability. The common engineering mistake is to check only deterministic margin at time zero. That misses the tails, and the tails are where failures begin. A more reliable approach is to monitor beta, or probability of failure, as degradation data accumulates. Once the trend shows the distributions moving toward meaningful overlap, the team has actionable options: redesign geometry, improve materials, reduce scatter, control use conditions, or add maintenance limits. Slide 9. The goal of reliability engineering is not to pass a beginning-of-life test. The goal is to preserve separation between stress and strength across the full intended life of the product. That requires degradation-aware design, accelerated life testing, and field-informed modeling. In other words, do not just verify margin today. Prove that the margin survives tomorrow.